Ionic radius. Ionic radius refers to the radius of anions and cations. So instead of atomic radius, when we're talking about an atom that has a neutral atom that has all of its electrons and protons, we're actually talking about, when we talk about ionic radius, we're talking about the radius of anions and cations, positive ions and negative ions. So what we notice here is that metals tend to lose electrons forming positive ions. So their ionic radius is smaller than their atomic radii because when you lose those electrons, it's easier to pull in the remaining electrons, so those electrons are pulled closer, making the atomic radius smaller. So for a metal, let's say Na, if Na is big, when it becomes Na plus, its atomic radius gets smaller. So it moves from this size to this size when we're talking about its ion. Nonmetals tend to gain electrons, so they form negative ions because now they have gotten more negative energy, so now they're more negative, and their atomic radii are larger than their atomic radii because when you add more electrons, it's easier for them to spread out because the attractive force of the protons isn't as much on those new electrons. So if I had this as, let's say, Cl, now Cl is going to become bigger because it has gained a new electron. It's going to be Cl negative. And so it moves from being smaller to being bigger. And we can see this if we look at the periodic table. We're going to notice that the metals on this side, they're going to get their ionic radii get smaller. So they're going to be much smaller here than they were before. And they're in the nonmetals where they are attracting more electrons. Their ionic radius is bigger. So we have to remember when they ask you about relative size of ionic radius that you have to remember the comparison between atomic radius, knowing that ionic radii are smaller here because they lose electrons, and here they are bigger than usual because they gain electrons.